Okay, today's Monday, December 9th, and we're starting a brand new module today. We're doing Module 3, and we're doing Lesson 1 from Module 3. Okay, and today we're going to use two different tools, actually three different tools. We're going to use a number line, something called a rectangular fraction model, which you're going to see is kind of looks like an area model. Okay, and of course we're going to use numbers to help us make what's called an equivalent fraction. And the idea of equivalent fractions should be a review from 4th grade. But I'm going to show you how to use a number line and rectangular fraction models to make equivalent fractions. So we're less focused on whether or not we can make equivalent fractions, because I know you can, because you learned that in 4th grade. But we're going to focus on using these new tools or these new skills or strategies to do it. Number lines and rectangular fraction models. Make sense? Good. This problem is asking us to figure out how many kilograms of rice are in each container, right? Of course, we know all together there's 15 kilograms. So I'm taking 15 kilograms of rice. We need to draw a tape diagram because to RDW, right? So we have 15 kilograms. And we're dividing it equally into 4 containers. So I'm going to split this up into 4 containers. We're trying to find out how much is in one container. What math equation could I do in order to figure out how much rice is in each container? Addison?
15 divided by 4.
Oh, we're dividing. Okay, so of course I'm going to ask you, is this a sharing division problem or a grouping division problem? Sharing, because we know exactly how many groups do we have? 4 groups, and we want to figure out how much can be shared equally. So this, you guys are getting the hang of it. Very good. This is a sharing division problem. Now, something interesting before we divide is that it tells us to express our answer as a decimal and as a fraction. I wrote this on purpose to remind you that numbers that are less than 1, or a portion of 1, part of 1, numbers that are not a whole number can be expressed in 2 different ways. Decimals and fractions can represent the exact same amount. Do you guys agree? If I give you $0.5, how much am I giving you? Half of a dollar. If I give you 1/2 of a dollar, how much am I giving you? 50 cents. So do you see how 0.5 is equal to 1/2? So a fraction and a decimal can be the same. Let's divide and see what decimal and fraction are equal here. Can I divide 1/10 into 4 equal parts? Can I? 1/10 into 4 equal parts. 1 dot. Can I divide it into 4 equal sections? No. So I have to regroup it as 15 whats? How many dots can go into each section?
3.
Okay. And how many would I use up?
12.
Okay. So how many are left?
3.
So what you're telling me is that I have 3 kilograms left, right? Right? If I were to divide it, I would have 3 kilograms of rice in here, 3 kilograms of rice here, 3 kilograms of rice here, and 3 kilograms of rice here. And all together in the end, I would have 3 kilograms of rice left, right? If I have 3 kilograms of rice left, here's 1 kilogram, 2 kilograms, and 3 kilograms. And I have to split it equally into 4 containers. Wouldn't I have to split each one into 4 containers? And this one goes here, this one goes here, and this one goes here, this one goes here, this one, oops, this one goes here, and this, right? Don't they each get 1/4 from each one? Yeah. So how much would each one get? 3 and 3/4 of a kilogram. Do you guys see that? Yeah. So we can express our remainder as a fraction by saying it's 3/4. Do you guys see that? So as a fraction, it's 3.34. Okay, kilograms. But let's continue to divide and let's see what happens next. Okay, if I have 3 kilograms left, is that the same as 30 somethings?
Yep.
30 whats?
10.
Okay, so what's 30 divided by 4?
7.
Okay, I use up 28, right? How many are left?
2.
Okay, I can write that as 20.
Hundreds.
What's 20 divided by 4?
5.
Right, so as a fraction, it could be 3 3/4 kilograms, but as a decimal, it's 3.75 kilograms. Okay, so you can see how you can express it as a fraction or as a decimal. Do you guys see that? Very good. So what I want to remind you here is that when we talk about fractions, we're talking about numbers that are part of a whole, right? And so the fractions always have 2 parts. The first fraction we looked at was 1/2. The numerator is the number at the top, yes? And that tells you how many of the sections. So this part right here is 1 section. Do you guys see that? Out of a total of how many sections? 2. Because you can see there's exactly 2 sections there. In the case of 1/3, this is 1 section out of a total of 3 equal parts. Okay, and the bottom number is called the?
Denominator.
Very good. So that should be review from before, okay? So we did this really quick paper strip activity to remind you what a fraction means. As a reminder, today we are using number lines and rectangular fraction models, which is what we see at the bottom here, to help us make equivalent fractions. Before we talk about equivalent fractions, we have to remember what is an equivalent fraction. What does the word equivalent mean? Everyone? Equal or same. So we're writing fractions that have the same value. Okay, so if I have the fraction 1/2, here I have my number line, yes? You can see a number line is a never-ending line. That's why there's arrows on each side. And when I move to the, what direction is this?
Right.
To the right, the value gets, and as I move to the left, the value gets forever and ever and ever. Good. So if this right here on my number line is 0, and this is 1, where would 1/2 be? Right in the middle. Okay, so we can label this as 1/2. Now, 0 would be 0/2. Do you guys agree? And 1 would also be 2/2. Do you guys agree? If I have 2/2, is that 1? Go ahead and draw this number line in your notebook. And we can show that 1/2 is exactly right there. Now, we already wrote something that's equivalent. We wrote two things that are equivalent. 1 and 2/2 are equivalent. Do you guys agree?
Yep.
And 0 and 0/2 is also equivalent. Okay. Today, for today's math notes, you want to make sure that you write down exactly what you see on the board, because these are some new strategies that I'm presenting to you. So make sure you copy down everything exactly as you see it. So one way we can show equivalent fractions is using number lines, by writing different labels for the same value on the number line. No matter what I call it, when I'm at this point, I'm always at 1 or 2/2, right? Same thing. Whenever I'm at this point right here, I'm at 1/2. And I'm going to show you that there's other things we can call it. Now at the bottom, I want to show you how we can use rectangular fraction models to show 1/2. In this first picture, I have a rectangle. And it's very important to label and show that the entire rectangle is equal to 1. Go ahead and draw that. Okay, I'm going to cover up the rest so that we don't get distracted. Now, if I want to show half of that rectangle, I can cut it directly in the middle in half and shade in half of it, and I can label that half is equal to half. Do you guys agree? Now, what happens if I cut it this way? Again, right now, how many sections do I have in this rectangle? 2. And how many are shaded?
1.
Okay. What happens if I cut it like this? Now, how many sections are in that rectangle altogether?
4.
And how many sections are shaded?
2.
So before there were 2 sections altogether and 1 was shaded. So 1 out of 2 were shaded. Now 2 out of 4 are shaded. Did I change the amount that's shaded?
No.
No. So what that means is if I were to, give me one second. Okay. If I were to cut it in half like I just did, I changed the top part into 2 sections, right? There's now 2 sections that are shaded. 1 times 2 equals 2. And all together, there are 4 sections because I cut each one in half. Does that make sense? So therefore, 2/4 is equivalent, or it has the same value as 1/2. Very good. What if instead of cutting each one into 2 parts, I cut each one into 3 parts? How could I write that? Before there was 1 part that was shaded, but now how many parts are there that are shaded?
3.
So I did 1 times 3, right? Which is equal to
3.
all over. How many parts were originally there?
6.
No, how many parts were originally there? 2. And I cut it each one into 3 sections. So 2 times 3 equals?
6.
So 1/2 is also equivalent to 2/4, which is also equivalent to
3/6.
Good. Okay, and last but not least, what happened here? I cut each section into 4. So following the pattern, I could do 1 times 4 equals 4 as my numerator, all over 2 times 4, which is equal to 8. So what fraction is also equivalent to 1/2? 4/8. So back onto my number line, instead of writing 1/2, I could also write what? What's something else I could write that's equivalent?
5/10.
Okay, but let's use the examples that we have here. 2/4, which is also equal to 3/6, which is also equal to 4/8. which, yes, would also be equal to 5/10, right? Very good. All fractions have two parts. The top part is called the numerator, and it tells you how many of the sections we're talking about. The bottom number is called the denominator, and I remember this by thinking D starts with down, or denominator starts with D, and down also starts with D. So the number that's down at the bottom is called the denominator. And that number tells you how many total equal-sized sections your whole has been cut into. Okay? Today we talked about how equivalent means it has the same value, or it's equal. So equivalent fractions all have the same value. Finally, let me leave you with this thought. You should be able to answer this question. Is a fraction always less than 1? Why or why not? Please answer that question in your math notebook.